Welcome back with another lecture. And this lecture, we're going to go through halohydrine formation. And halohydrine formation, we will have a halide on one side of the double bond and OH and other side. And double bond, it will turn to single bond. That means the alkene will be saturated and it will turn to alkane. Okay. And thing that you need to be careful about it, where the halide will be located. Halide will be on a carbon with less substituent. It means the product is going to be anti-Markov products. And it's supposed to be on more substituent, but as you see, it says on less substituent. Well, OH, it will be on carbon with more substituent. Okay, the way we're going to run the reaction, we run the reaction, okay, this time in the presence of Cl2, Br2 or Cl2. You can use either of this as a source of halide, and the solvent, it will be a protic solvent, something like water, or you can use alcohol. Let's say you replace one of the hydrogen by methyl group. Okay, and this piece, it can behave as a nucleophile. Okay, let's go after it. So we have a protic solvent, and our solvent, it can be water or methanol or ethanol. First step of this reaction, it will be this. Okay, similar to halogenation, we will have a bromide bridged between two carbons. Okay, and as you know, we have two hydrogens here. Okay, so one of the hydrogen, it will be back, and the second, it will be facing to us. And that hydrogen, it will be here. Okay, next step. Okay, we said for halogenation, we said our nucleophile will be bromide or chloride. This case is not gonna be that. You will use water, okay, as the nucleophile, and water is gonna attack either this carbon or say that carbon. Okay, either one. Okay, so so we said water, it can attack this carbon or that carbon. Okay, technically both of them are possible, but before we add water, let's see which one of this carbon is more stable. And when I say more stable, remember, the bromide has a positive charge, and that positive charge is not going to be 100% located on bromide. And these two carbons also, they will have to some extent, they will have some positive charges. Okay, and I have a carbon. Okay, I have a carbon that is a tertiary carbon here, and other side I have a carbon that attach only to one carbon, and that's going to be primary carbon. Okay, so now question is, which one of this is more capable of handling the positive charge? Clearly the tertiary carbon. Okay, what does it mean? It means this. Okay, I'm going to just copy paste this section. Okay, let me erase those. Okay, next step, I'm going to increase the size of this. Okay, here, what does it mean when I say the tertiary carbon is more stable? It means this. Okay, it means this bond, it will be a weak bond. Okay, let's make this one a weaker bond. Okay, well, the one that attached to carbon number one, okay, or the primary carbon is a solid line. The tertiary is dashed line. It means this one is weaker bond. If it's a weaker bond, when the nucleophile wants to attack these two carbon, it will find this carbon with more positive charge, and is attached to bromide through a weaker interaction or weaker bond. So this bond, it will be easy to break it. That one, it will be easy to break it. What does it mean? It means your nucleophile, which is H2O, it will be added to the tertiary carbon. Okay, so this is going to happen. I will have two. I will have here methyl. There, one methyl is here. Okay, this is going to be CH3, CH3, and we have hydrogen here. Okay, another hydrogen is facing to us. Okay, and the bromide, we said we're going to add it on the first carbon. Well, where, okay, it will be added there. This is going to be war, and it has a positive charge. And of course, solvent is going to take one of this hydrogen, and at the end, it will turn this one to, it will turn it to OH. So we will have OH attached to carbon that has more substituent. And as you see, this carbon is a tertiary carbon, while that carbon is a primary carbon. And the product we got, it has a bromide on a carbon with less substituent. And that's the reason that I called it anti-Markov product. Okay, that was the reason for it, because bromide is sitting on a carbon with less substituent. Okay, now what will happen here? Okay, what will happen if we have, for example, say we have a carbon, and this carbon, it has a ring, and as you see, we have one that is a tertiary, second one is a secondary, and if you introduce bromide, the presence of, for example, water, okay, first step, you will get this intermediate. And now bromide, it will have a positive charge. Okay, and water, okay, will provide this as a nucleophile, and OH as a nucleophile, it will attack, okay, these two carbon. Okay, the question is which carbon? We have a tertiary carbon and secondary carbon, and OH is going to attack the tertiary carbon. And in that case, if we attack the tertiary carbon, we will have OH in this position, and the bromide is going to be here. Okay, and of course, I'm gonna get enantiomers. Okay, so this molecule technically is capable of generating stereocenters. So let's highlight them and talk about the stereocenters. Okay, so for example, let's assume the bromide is on the top of the molecule, and in that case, if a bromide on the top of the molecule, okay, and because the bromide is on the top of the molecule, and OH, when OH is reaching the molecule, is going to reach it from the back. So OH, it will be here. What does it mean? It means bromide, the methyl, okay, methyl, it will go up. So this is going to be the CH3. Okay, and now what will happen with the bromide? Bromide, it will go up, okay, and hydrogen, this hydrogen, the hydrogen that we have there, that hydrogen, it will go back. So now I got bromide here. Okay, now let's assign the configuration for them. Okay, and this is going to be number 1, that's going to be number 2, and this is number 3. So I go 1, 2, 3, supposed to be R, because methyl is the 4th one, is facing to us. So this one's supposed to be R, we get S. And for the second one, I go 1, okay, 2, 3, this is going to be R. So I got S and R, okay, I got S and R. Can I get R and S? Yes. Another product, it will be the enantiomer of it, which is going to be a R and S. Okay, so we can get, you know, like a two stereo centers in here. Okay, as you see, we got the two stereo centers. And do I have another stereo center? Yes, the third stereo center is there. I am not talking about that one. And but we do have the third stereo center there. Okay, now what will happen if you run this reaction in the presence of say methanol? Okay, in that case, you will get these two products. Okay, you get the bromide somewhere here. So I'm gonna show it by wavy line. That means the bromide can be up or down. And okay, the CH3, it will be attached to a carbon with more substituent. Okay, so the carbon with more substituent, it will have the OCH3, and the one with less substituent, the one that it has hydrogen, it will have the bromide attached to it. And what's the difference between this versus war? And when you had war, okay, this one was the product. Okay, let's put them side by side. I updated my GoodNote software, and I'm not that familiar yet with it. Okay, so forgive me about the, you know, some issues that I have with software. Okay, so when we have, okay, when we have water, okay, the product was OH and bromide. If you're using alcohol, you get bromide there, but here you will have OCH3. So just simply highlight this hydrogen. That hydrogen will be replaced by CH3 or like ethyl or any other, you know, like a group. And this is the difference between, you know, having water as a solvent or alcohol. And I'm going to stop here and thank you very much.